Okay, so here we go. We've got a question about algebra, 2x squared plus x equals 10. Now clearly we can solve this using algebra and do this by hand. And the key to solving quadratics is factorising, right? The mathematical gods put factorising on this earth to help us solve quadratics. But of course we've got a GDC, so let's go and find out all the different number of ways we can solve this. First of all, I'm going to use a graphing technique. So remember, to solve any equation, graph the left-hand side, graph the right-hand side, find the intersection. So let's go ahead and do that. Doc, insert a graph, and this is 2x squared plus x, left-hand side. Control G shortcut, 10, the right-hand side. Go and change this to, let's say, 12, and you can see there's two solutions. Menu, analyze graph, intersection, click, click. Negative 2.5, right? The x value, negative 2.5. Menu, analyze graph, intersection, click, click, and 2. So x equals 2 or x equals negative 2.5. While you're on this graph, let me show you a different technique. Menu, trace, graph trace. Now, this little tracey point will lock into points of interest on the graph, but notice it's not locking in on the intersection point there, right? But it does lock into the 0, all right? And it does lock into the minimum, and you can see down here that the minimum on this graph is at negative 0.2, okay? So the graph trace is okay. It locks in on the important points on the graph, the zeros where it crosses the x-axis, the minimum, and the 0 again, but it doesn't automatically lock into the intersection, all right? Menu, trace, trace all. Okay, so now look, we're actually tracing both graphs. I wonder if, I see even here, this doesn't actually lock in on the intersection point, right? So the graph trace is only good for tracing points on a graph. I mean, it's quite nice, but it doesn't really get us what we need, okay? So that's menu intersection. But there's a better way of doing this, right? Because if we go back to the question, of course, with just a little bit of algebra, and only the tiniest bit, if we actually rearrange and bring the 10 across, can you see that we actually only need to type in one equation now? So let's go ahead and grab this. Let's go doc, insert another graph. And now I'm going to do 2x squared plus x minus 10. And now we actually can see that we want to solve where the graph equals 0, so where y equals 0. So in fact, we just want this point here and this point here. Menu, analyze graph, and look, the zeros. Click before, click after. There's the negative 2.5 again. Menu, analyze graph, the zeros. Click, click, and there it is. Now that's a little bit better because remember on this first graph, we had to rescale, right? We had to find that 10 here. We had the blue graph and the red graph. We needed to find the intersection points. With everything on one side, all we have to do is find where the graph chops the x-axis, right? So we're only searching in one place. We don't have to zoom up and down the y-axis. So that's pretty helpful. But there's an even better way. So if we go doc, insert a calculator page, all right? Do you remember our taste of the little nsolve? Menu, algebra, nsolve. And we'll go for the original equation, 2x squared plus x equals 10, right? I think that's what it was, yep. And we want to solve this. There's an equation there. Press enter, and it says, oh, look, it's missing an argument. Now, we actually have to tell the calculator, comma, x, the variable we're solving for. So nsolve needs to have a variable. Boom. Oh, 2. Well, it's found this solution, the 2, but it's not found the negative 2.5. So nsolve just zips up and down the x-axis, finding the zeros, but it stops at the closest one. So the closest one to the origin is this one. It's missed this one. So it could be a bit of a problem, but actually, go and grab it. And now we're actually going to search from 0 down to negative 100. Invalid bounds, right? So now, instead of 0 down to negative 100, if we go and grab this, we actually have to have it negative 100 up to 0, right? So from left to right, smallest to biggest, boom. So you can actually tell nsolve to search somewhere along the x-axis for the solutions, right? So that's a top tip. But that's a bit of a pain, isn't it? So the ultimate now is menu, algebra, polynomial tools, find roots of polynomial. Okay, the degree is 2 because it's an x squared, and look, all we have to do is type this in. Now notice all of the terms are on the left hand side equals 0 on the right hand side. All right, so for sure what we're going to need is we're going to need a little bit of rearranging of the original. So we need this form. All right, so to find the polynomial root finder, to find the zeros of a polynomial many terms, we need to have equals 0, right? So it's this particular expression here. So let's go back to it now. Menu, algebra, polynomial tools, find roots of polynomial, degree 2, okay. And this was 2x squared plus 1x minus 10. So have a little look. The 2 here tags with how many x squareds, the 1 tags with how many x's, and the negative 10 tags with just the constant at the end. Press OK, off we go, bada bing, bada boom. So this is negative 2.5 and 2. This is the first x coordinate on the left and the second x coordinate, right? This isn't xy numbers in those nice parentheses. They are 2x solutions, right? So negative 2.5 and 2. That matches the negative 2.5 and 2 from here, and that matches also back to this graph, the negative 2.5 here and the 2 up here. Okay, so hope that helps. Polynomial tools, beautiful.